Good afternoon to all of you and welcome to this lecture on ETC 779. As you can see it from the slide, today I am going to take both the lectures 11 as well as 12. So, both the sessions we will be doing some problems related to ETC 779. Just to give you some background of whatever we have discussed earlier, you must be remembering we have covered present worth method, we have covered future worth method and we have covered annual cost method. So, these three methods of comparison of alternatives we have already discussed. In the current class, I am going to discuss about another method of comparison of alternatives using rate of return method. So, in this particular class, you are going to learn rate of return method of comparison of alternatives. You may note it down, rate of return method. Rate of return method of comparison of alternatives. Now, this is another method for evaluation. What other methods we have already discussed? Present worth method, future worth method and annual cost and worth method. These three has already been covered. Now, sometimes this method proves to be quite useful, rate of return method. You will find that it is very helpful and basically you can understand rate of return as an index of profitability. So, basically rate of return is regarded as an index of profitability. If you are getting higher rate of return means you are earning more, if you are getting less means you are earning less. So, this is kind of an index which tells you the status of profitability. Now, when you compare, when you see rate of return, there are many terms which you may be hearing when we discuss about rate of return. First term is MARR, minimum attractive rate of return. Even if you are not able to copy the slide completely, don't worry, I will be sending you today itself. The copy of the slides will be sent to you through mail. The first thing under rate of return is MARR, which is minimum attractive rate of return. Another term is internal rate of return, which I use the notation IRR, and the third one is incremental rate of return. We will use the terminology IROR, and finally there are external rate of returns that we are going to denote using ERR. So, these are four commonly used terms when we talk of rate of return method of comparison of alternatives. First one is MARR, minimum attractive rate of return, then you have IRR, internal rate of return, then you have incremental rate of return IROR, and then you have external rate of return ERR. Now, we will see each one of them individually, and first thing that we will discuss is MARR, minimum attractive rate of return. Now, when you see MARR, you have to understand that whenever companies do business, they have certain thing in their mind, certain margin, that below this I am not going to do my business. So, that minimum value below which a construction company won't be interested in a particular kind of alternative is known as minimum attractive rate of return or MARR. That means, it is that lowest level below which no one would be interested in investing the money. So, that this particular benchmark below which the companies won't be interested in doing the business is known as MARR or minimum attractive rate of return. Now, this MARR depends on so many factors. For example, it depends on the market conditions. If you find that the market is very competitive, the MARR value could be low. If the company enjoys monopoly, in those situations you will find that MARR value could be high. Then it depends on level of competition and cost of capital. These are primarily three most important influencing factors as far as MARR is concerned: conditions of market, level of competition and cost of capital. Now, for different industries, MARR values may change. For example, for software industries, it could be different MARR value. For a construction company, the MARR values could be different. If it is some other kind of industry, let us say petroleum and refinery industries, the MARR values could be different. So, what you find that the value of MARR is not constant across all the companies. Depending on what kind of industries you are working, the management may fix different MARR values depending on a number of factors such as market conditions, level of competition, cost of capital, right. These are some of the factors which influence MARR. And the second thing that you have to remember is MARR value is not constant across different industries. They vary because different industries work under different scenarios. So, naturally you can't expect that everyone would like to get the same amount of minimum attractive rate of return. For everyone it could be different. Now, you will be surprised to note that even within the same company, within the same organization, the MARR values may differ across different business units. Now, you will find that construction companies are large construction companies. If you see, they are divided into different strategic business units. They are called SBU, strategic business units. So, you take large construction companies, you will find that they have got a number of SBUs. SBUs is strategic business units. For example, there could be one strategic business unit doing business in buildings and factories. Another would be in infrastructure projects, roads, highways, airports. So, there could be one such kind of SBU. There could be another SBU like you will have petroleum and refineries. There could be water and wastewater treatment SBUs. So, you will find that even within the same company, they have different MARR values. Now, you will find that if the company faces large competition or rather stiff competition in a particular SBU, then they may be satisfied with even a low MARR. For example, suppose the company is having a SBU which is dealing in business in buildings and factories. Now, suppose that there are too many competitors available as far as buildings and factories are concerned. So, since too much of competition is there, so the company would even settle for low MARR value. But if the company is operating in niche area where the competition is very low, for example, if it is a tunneling work, right, if it is a dam work, there you can expect very few competitors. So, there the companies raise that MARR values. So, for one SBU, MARR could be somewhere low, for other SBU, MARR could be high. So, that is what is called minimum attractive rate of return. Suppose for buildings and factories, MARR value is 15%. What does this mean? That if in a project in which company is planning to bid, if they are expecting a return of less than 15%, they will not be participating in that project. Is it clear? Similarly, for suppose a tunneling SBU, strategic business unit, the company has set a rate of return target of 20%. What does this mean? It means that if in a particular project the company is expecting to get a return of, let us say, 18%, then in that case company won't be interested in doing that particular project. They may not be bidding for it, right? They are not interested because they have set a higher MARR value there. But if this particular return they would have been getting in, let us say, building and factories projects, they would have been more than happy to grab that particular job or project. So, this is the concept of minimum attractive rate of return. Now, this is one of the important yardstick. This is one of the important yardstick in evaluating investment options. So, what you do? Company has decided a minimum attractive rate of return. Now, based on the cash flow diagram of that particular project, you calculate what is the actual rate of return you are likely to get, and then you compare these two values. The expected rate of return, you compare it with the minimum attractive rate of return. If you find that expected value is more than MARR, you go for that. But if you find that expected value of rate of return is less than the minimum attractive rate of return, in such case you discourage that kind of investment option. So, this is the crux of this minimum attractive rate of return and its utility. So, just to summarize, what is minimum attractive rate of return? It is the lowest value below which company won't be interested in doing a business. Second, minimum attractive rate of return varies between different business sectors. Now, third thing, even within the same company, even within the same organization, MARR values may differ depending on level of competition, market conditions and cost of capital. Okay, this was as far as discussion on MARR was concerned. Now, we move on to IRR. It is very important term, internal rate of return, and that is why we will spend some more time in discussing this particular aspect. As far as definition goes, it reads like this. It is represented by symbol sometimes I star, or sometimes it is also denoted by ROR, rate of return. However, in our problem solving we have used the nomenclature IRR, right. So, do not get confused, they are all same. IRR, I star, ROR are all same. Now, it is defined as the interest rate which reduces the present worth of given cash flow to 0. So, as far as definition goes, it is very simple. So, it is that particular rate of interest at which the net present worth becomes 0. What is net present worth? It is the present worth of all the costs and difference between the present worth of all the incomings and all the outgoings. That you equate it to 0 and then solve this equation to get the value of I star or ROR or IRR. So, is it clear? So, if you try to put this in the form of an equation, it would look something like this. As I told you, it is nothing but the difference of present worth of benefits or rather income minus present worth of cost or outgoings. Outgoings are your cost, incomings are your revenue, right. Now, this is nothing but net present worth. Now, you equate this net present worth to 0 and find out I star. That means using this equation you have to solve I star or internal rate of return. So, this is what it is written over here. In principle, IRR can be determined by equating the net present worth of the cash flow to 0. And net present of cash flow is given by present worth of benefits or present worth of incomes minus present worth of cost. So, this you equate it to 0 and solve for I star value. So, this one example we will try to do, and then you will understand that although the equation looks simple, while solving it you will find that there are a lot of difficulties involved, because the formulas for calculating the present worth will involve, it has got a complex, complex formulas are used, and that is why you solve these equations only with the help of trial and error, right. So, when you say trial and error means you have to assume certain value of I star and then try to see whether present worth of benefits are more or present worth of cost are more. So, you will find whether the right hand side of this equation you are getting a positive value or negative value, and then you go on changing the value of I star, and then finally you get the value of internal rate of return. So, I have we will solve one example, it will become more clear. So, these are certain steps, I have written it in a stepwise manner, you can note it down. These are certain steps for computing internal rate of return using the equation which I had shown you in previous slide, that was present worth of benefit minus present worth of cost is equal to 0. For solving that equation, step 1 is assume a trial rate of return. Assume a trial rate of return I star, let us say it could be any value 5%, 10%, 15%, 20%, anything you assume, right. In step 2, what you do, count the cost as negative. This convention we are following right from the beginning, so nothing new. We are considering cost as negative and income as positive. Now, using this notation, find the net worth of all the costs and incomes. It is not difficult. Once you know the value of I star which you have assumed in step 1, this calculation can be performed quite easily. Next step is, if you find that the net worth is positive, what does this mean? That means the income from the investment is more than the cost of investment. That is why you are getting positive values, and the actual percentage return is higher than the trial rate. So, what you will do? Suppose at the given trial rate of return you find the net worth to be positive, that means what you are finding? That actual percentage return is higher than the trial rate. So, what we will do? In such cases, in step 4 you can see, adjust the estimate of the trial rate of return. We will adjust our assumption. Suppose the net present worth is coming to be positive, so we will reduce the next value. Again, suppose it is coming positive, we will further reduce it. We will go on reducing it till we get a negative value, because getting 0 directly would be very difficult. So, we will go on reducing the values of I star till the time we get a negative value, and once we have got one negative value, we can solve the value of I star by interpolation. How do we solve? By interpolation. We have got one positive value of net present worth, we have got one negative value of net present worth. So, in between we will try to find what value of I star would correspond to 0 net present worth. So, this is what is the sequence that we need to follow as far as computation of IRR is concerned. Now, we will take this problem, particular problem. You can just note down the cash flow. So, at the end, at the time t is equal to 0, there is a negative cash flow rupees 1000. That means 1000 rupees you have to invest, and at the end of year 1 you are getting rupees 4000, rupees 400. At the end of year 2 you are getting rupees 370, and at the end of year 3 you are getting rupees 240, and at the end of year 4 you are getting rupees 220. Now, the question is to find the internal rate of return for this particular investment option, in which I am supposed to invest 1000 rupees now, and I am going to get a return of 400, 370, 240 and 220 at the end of year 1, at the end of year 2, at the end of year 3, at the end of year 4 respectively. Is the problem clear to you? Okay, so we will illustrate step by step how to proceed for such kind of problem. So, I will just take this problem. You have 1000 rupees to invest at time t is equal to 0, and you are getting a return of 400, 370, 240 and 220 at the end of year 1, 2, 3 and 4. Now, what is your step 1? Step 1 is assume a trial rate of return. So, step 1, assume trial rate of return. Let us say it is 15%. So, I will assume let I star is equal to 15%. Clear? Now, I have to calculate net present worth NPW. Step 2, net present worth I have to find for 15%. How I will get? It would be present worth of benefits minus present worth of costs, right? So, what is the present worth of benefit? It would be 1000 itself, because this is at time t is equal to present worth of benefits would be, it would be 400 divided by 1 plus 0.15 raised to power 1 . I am using the formulas, you can use the table also. I will show how to do that way also, but right now I am trying to do it in a simple manner. Plus 370 divided by 1 plus 0.15 raised to power 2. What I am doing? This 400 I am trying to bring it at time t is equal to 0, and interest rate I have assumed to be 15%. So, 1 plus 0.15 raised to power 1 plus 370 divided by 1.15 raised to power 2 plus 240 divided by 1.15 raised to power 3 plus finally 220 divided by 1.15 raised to power 4. So, all these 4 terms are what? They are giving you present worth of benefits. Now, I have to subtract present worth of cost. Now, it so happens in case of cost, it is straight away minus 1000, because it is at time t is equal to 0 itself. It is at time t is equal to 0 itself. What is the value? What sign convention we have used? We have assumed cost to be negative and benefits or incomes to be positive. This is what convention we have been using throughout our lecture. What is the value of this net present worth? Is it coming in positive or negative? Technology class? How much is it? Some positive value, fine. Okay. So, when you are getting positive value of net present worth, what does this mean? This means we have to reduce the I star value. We have to reduce the I star value. That means we have to rework it out. Now, I can assume, let us say I star is equal to 5, because from 15 now I have brought down to 5. Yes, I have brought down to 5 now. So, what I will do is, I will do this calculation again. I will do this calculation again at I star is equal to 10, let us say 5%. This is trial 2. And now the net present worth would be 400 divided by 1.05 raised to power 1 plus 370 divided by 1.05 raised to power 2 plus 240 divided by 1.05 raised to power 3 plus 220 divided by 1.05 raised to power 4. And this I subtract it again from 1000. Now, this value, if you try to calculate, you will find that it is coming in negative. You will get a negative value for this. So, what does this indicate? That means we have to increase the value of I star, right. So, I will increase this value in trial 3. Here I will assume now, let us say I star is equal to 10. I star is 10%. So, if you see trial 3, you will get a value like this: net present worth would be equal to 400 divided by 1.10 raised to power 1 plus 370 1.1 raised to power 2 plus 240 1.10 raised to power 3 plus 220 raised to power 1.10 raised to power 4 minus 1000, and this you will be getting value as 0. This is a special problem in which through trial itself you are able to get this 0 value. In some of the cases it may not be working like this. In such cases you will have to use interpolation. So, you will have some positive value of net worth, you will have some negative value of net worth, and in between this there would be some value of I star at which there would be in net present worth would be equal to 0. So, this is the process for computing net present worth. Now, this particular problem I solved using formulas. The same problem I could have done it using interest factor tables also. For example, I would have taken net present worth as present worth of benefits minus present worth of costs. So, this would be, how do you calculate present worth? You are given F, you want P. So, you will write P given F at 10% for year 1, this multiplied by 400, right, plus P given F 10% year 2 multiplied by 370 plus P given F 10% 3 multiplied by 240 plus P given F 10% 4 years multiplied by 220 minus 1000. 1000 we are writing as it is because this is at time t is equal to 0. So, its present worth would be same as that given in the cash flow diagram, and you will find that this is also going to give you the same value 0. This is at I is equal to 10%. You can cross check it using table. Now, these are various steps through which you calculate the internal rate of return. In this particular problem, which was formulated in such a way that you are getting an exact value of 0 as far as our trials are concerned, but in most of the cases you may not be able to get 0 value in one go itself. So, in such cases you should try to look for one positive value and another very close negative value to it, and then you should try to use interpolation and get the value of I star corresponding to net present worth of 0. Now, here you should be careful not to use a very large gap. Say for example, if there is a large gap between your plus value and minus value, then the rate of return that you will be getting will be very approximate. So, that is why I am emphasizing that you should try to use bring down your values to very close gap. Say for example, plus value and minus values are very close. In such cases, your linear interpolation can still give you fair enough result. So, this is the precaution that you have to keep in mind. We will do one more problem. Okay, before that, I will throw some more light as far as this particular problem is concerned. You will find that the cash flow which we have given you as a problem, you can find there is a particular design to it, and this particular design has been design of cash flow has been made to show you the basic concepts of internal rate of return. Now you can understand this like this. Just try to see this particular slide. Whatever cash flow information was given to us in the form of a diagram, that we have converted it into a table form. Now in this you can see that the first column is showing end of year 0, end of year 1, end of year 2, end of year 3, end of year 4. So the first column is giving you the end of year. The second column is giving you the cash flow. For example, at the end of year 0, you are getting a negative cash flow minus 1000. What does this mean? That means you are investing 1000 rupees. We have used the symbol, we have used the sign as negative, which means that you have to invest. So at time t is equal to 0, you are putting 1000 rupees. At the end of year 1, you are getting 400. At the end of year 2, you are getting 370. At the end of year 3, you are getting 240. And at the end of year 4, you are getting 220. Now, just a while ago, I was telling you about the design, right? So this 400 figure, 370 figure, 240 and 220 figure has been designed in such a way that at the end of year 4, at a particular rate of return or a particular interest rate, you will get 0 value. How? Let us say at the beginning of a period, you have invested 1000 rupees, right? Let us say the rate of return is 10%. Rate of return is 10%, and at the beginning of a particular year or at the end of year 0, you have invested 1000 rupees. So how much interest you would generate after 1 year at rate of return 10%? It would be 100. 1000 into 0.1. So this is what you can see, the third column, or rather fourth column. This 1000 rupees will earn you rupees 100 after 1 year. So that means the 400 rupees that you have got at the end of year 1, out of that 400, 100 rupees is going towards interest and 300 is going towards principal. So this is what you have to understand. So out of 400, 100 has gone towards interest, and your principal will get reduced only by 300. Although you are getting a return of 400, but not all 400 is going towards reducing your principal. So at the end of year 1, you will find that your principal reduces to 700. 1000 minus 300, that is 700. Now this particular 700 in 1 year will have an interest charge of 70 rupees at 10% interest rate. So that means out of 370, 70 rupees is going towards interest and 300 is going to reduce your principal. So now your principal for the next year would be 700 minus 300, which would be 400, right. Now, this 400 in 1 year interest charges would be 40 rupees at a rate of 10%. So, out of 240, 40 goes towards paying interest. So, 200 is the effective reduction from your principal. So, the net principal now becomes 200, and for which you have to pay an interest of 10%, that it will be equal to 20 rupees, right. So, out of 220 that you are getting it at the end of year 4, 20 rupees is towards interest charges and 200 is towards reduction of your principal. So, what you find at 10%, you are getting a net value, net present worth equal to 0 at the end of year 4. So, this is that special interest rate at which your net present worth for a given cash flow becomes 0. So, this is another way of understanding, the internal rate of return. Now, we will take one more problem, but before that there are certain important points as far as internal rate of return is concerned that you must pay particular attention to. For example, you might have noticed that from the equation which I gave you to calculate the rate of return, that it is not possible to calculate the rate of return for the cash flows which involve cost alone. Similarly, it is also not possible to calculate the rate of return for the cash flow involving revenues alone. Now, this you can see it from this particular problem. For example, if you have got a problem like this, which says that 1000 rupees I am investing at time t is equal to 0, 200 at the end of year 1, 200 at the end of year 2, and 200 at the end of year 3. Suppose this is the only information given to you. What kind of cash flow diagram is this? This is called cost dominated cash flow diagram. Cost dominated cash flow diagram, right. Now, it is not possible to calculate the rate of return for this. IRR is what? For this, not possible to calculate. Not possible to calculate. So, for such type of problem, we are unable to calculate the internal rate of return. Now, we take some other type of problem in which, let us say, you are given an information that let us say you are purchasing a equipment and you are getting a return, let us say not this, at time t is equal to 1, t is equal to 2, t is equal to 3, and let us say at t is equal to 4. You are given information on revenue alone. So, this is called revenue dominated cash flow diagram, right. Here also it is not possible to calculate IRR. So, here also it is not possible. So, this is what I mean when I say that it is not possible to calculate the rate of return for the cash flows involving cost alone or for the cash flows involving revenue alone. Now, another point that you should note is this particular method, IRR method, you should not use for ranking of projects. Never ever use this particular method for ranking the project. Say for example, you should not use this method in finding the rank. Say for example, the investment option with 15% IRR, let us say it is rank 1, 14% IRR rank 2, 13% IRR rank 3, and this way you should not base your judgment. You will find that the decision which you will be taking, if you are using it for ranking purposes, will not be in line with the results that you obtain through other methods of analysis. For example, we will take one problem which we will solve using all the 4 methods which we have covered till now. One was present worth method, annual cost method, future worth method and internal rate of return method. You will find that if you use this method for ranking or finding the relative weightages for different alternatives, your answers or your decisions that you will be taking will not be similar to the ones that you will be taking otherwise using methods such as present worth, future worth and annual cost methods. So, this point you have to be very careful. Now, this particular problem will be these points will be more clear if you see how to calculate the internal rate of return. I will give you one more problem. You please note down this problem and try to find out its internal rate of return. This will give you more practice as far as the concept of internal rate of return goes. So, what the problem says that at time t is equal to 0, you are putting up $80,000. At the end of year 1, you are getting a return of 1500 if you see in the plus side, and you have to pay $850 towards, let us say, its operation and maintenance. This continues for next 5 years. That means at the end of year 1, at each end of year you are getting $1500 and towards maintenance and operation you are paying $850, and you can sell this particular equipment. You can sell this particular equipment, let us say, at the end of year 5 at $15,000. How much? At $15,000. So, can you just find the internal rate of return for this particular cash flow diagram? Again, you will have to use the same process. Step 1, assume some trial rate of return. Then calculate the net present worth. That means present worth of benefits minus present worth of costs at that particular I star value. If you find that it is positive, then you have to reduce the value of I star, right. At this I star, again calculate the net present worth. Suppose it is negative, right, then you have to increase it, right. So, idea is to close this gap, and you should be as close as possible to that 0 value of net present worth. So, this particular problem you please try, and then I will also show you in a step by step manner how I have done it, and you can also do in the similar manner. For example, what you can do is you can draw the cash flow diagram. You have $80,000 here, right, and every year you have to spend another $850, 850 for next 5 years, 850, and you are getting a return also every year at a rate of $1,500. So, I am writing it on positive side. Now, besides this, you are getting a salvage value of $15,000. Now, this salvage value is the money that you are realizing once you sell it at the end of year 5. Let us say this is t is equal to 0, 1, 2, 3, 4 and 5. So, at the end of year 5, you are selling this particular equipment or this particular asset and you are getting a return of $15,000, right. Otherwise, every year you are getting a return of 1500, 1500, 1500, here also 1500, and every year you have to spend $850 on the operation and maintenance. Remember, we are using the convention that all the expenses and all the incomes are at the end of a particular period. So, although we are showing this at 850 at the end of year 1, we must have been spending this money throughout the year, but just to simplify our calculations, we have assumed this particular thing that all the expenses and all the incomes are at the end of a particular period. So, here what I will do is, I will take some I star value, trial 1 I will do, trial 1, let us say I star value is 15% to start with. Now, at this point of time I will calculate the net present worth. So, net present worth would be let's say this side is in negative, this is positive. So, first I take positive values, right. So, it would be P given A, right, what 1500 we are getting every year up to 5 years. So, that can be treated as annuity. So, I am interested to convert this annuity into time t is equal to 0. That is why I have taken P given A at an interest rate of 15% at a for a period of 5, this multiplied by 1500, right. Now, there is one more in positive side, this $15,000. So, this is F, future sum, I am interested in finding its present value. So, plus P given F at an interest rate of 15% for a period 5, this multiplied by 15,000. So, till here it is all benefits. Now, I have to do for cost. So, minus 80,000, this cost is at time t is equal to 0. So, its present worth would be same amount minus 80,000 minus, now for these 850s at for next 5 years, I will be using P given A at 15% for 5 years, this multiplied by 850, this multiplied by 850, right. Now, if you try to calculate this, you will get a negative value for this. Just cross check it. You should be getting a negative value for net present worth, a negative value for net present worth, right. So, what does this mean? Negative value means It has to be increased or decreased. Okay, what I will do? I will leave at this point for you to complete this particular problem, right? And in case you have got any doubt on this particular problem, you can always write to me, right? Now what we do is, you have to follow the same process. Assume a trial rate of return, calculate the net present worth, find the value of net present worth. If it is positive, you revise the I star value, right, and you go on revising till you get a negative value, and then finally you have to interpolate these values and then you can get the value. Okay. Now one thing I told you, that this particular method should not be used for, this particular internal rate of method should not be used for ranking of projects, right. It will give you erroneous result. That means it will not be giving you results which you will be getting it through other methods, Now in order to take care of that, there is another method called incremental rate of return method. It is called incremental rate of return, right. Now the term incremental and the method of incremental analysis, it can be performed for all the methods which we have discussed till now. So there could be incremental present worth method, there could be incremental future worth method, there could be incremental annual cost method. So in all such cases you can use this incremental analysis. But before going into those incremental analysis, we will first cover incremental rate of return analysis. So as you can notice from this particular slide, it says that if an alternative requires a higher initial investment than the other and the evaluation is of the rate of return on the increment of initial investment, the return yielded on this extra investment is called the incremental rate of return, right. What happens, say for example, we have got two options. In one option, I am putting 1 lakh. In another option, I have to put 5 lakhs. Or let us say in one option, I have to put 1 million. In another option, I have to put 5 millions. Right? So in such cases, what we do is, in order to use incremental analysis, we convert the problem slightly. For example, naturally you will find that if the initial investment is low, your operation and maintenance cost is going to be higher. This is a common phenomenon you must be noticing. Whereas if your initial investment is high, you will find that the cost to operate and maintain that particular alternative or that particular asset would be little less. So what we do in incremental analysis is, we try to find out what is the additional benefit we are getting, by that extra investment. Suppose in one option we have to invest 2 million. Yeah? Visual is not clear. It is not clear.
Yes.
Should we stop then? Should we continue after some time? What should we do? Should we stop? Should we stop here? Okay, then we break here. We break and then we reassemble, right?